here's problem 6. We're given the differential equation dy dt equal to y minus 1 times 4 minus y times y minus 6 with the initial condition that y of 1 equals 10, and we're asked what the limit as t goes to infinity of y of t is. So it might not be super obvious here, but the point of this, and I know I wrote it in the problem, but I can see being given this question without any other information being asked to like figure out what's going on. The whole idea here is that if we start at 10 for y, where do we end up? Well, we need to know what our equilibria are, 1, 4, and 6, the things that make the derivative 0, and if they're stable or unstable. So I'm going to draw my phase plane. I think that's what it's called, right? Yeah, the phase plot, phase plane, whatever. So on the horizontal axis go the y's. On the vertical axis goes the dy dt, which sometimes people call g of y. And then on my horizontal axis go my intercepts, positive 1, positive 4, and positive 6. Okay. So then we need to draw the phase plane. Now each of these intercepts is going to cross the horizontal axis, right? Because they all have odd multiplicities. And that's usually going to be the case. So we need to figure out if we're starting above or below. So just plug in 0 for y to see what your vertical axis intercept is, right? Your dy dt intercept. So if you plug in 0 for y, you get negative 1 times positive 4 times negative 6, which is going to be, I don't really care that it's positive 24, I just care that it's positive. So here's my first y value. No, sorry, my first dy dt value, right? So when y is 0, dy dt is 24. And then I have to hit that point. I have to cross through, and then cross through, and then cross through. Okay, here's all I really care about. When the derivative is positive, right, my derivative, right here, dy dt is positive, that means y is increasing. So everywhere here where the derivative is positive, the y values have to go to the right because they are increasing. Everywhere here where the derivative is negative, the y values have to get smaller. Everywhere here, the derivative is positive, the y values get bigger. Everywhere here, the derivative is negative, the y values get smaller. So not that the question asks you this, but it is worth noting that both 1 and 6 are stable equilibria, because if you start anywhere around them, you get pushed back towards them. Whereas 4, the arrows point away, 4 is an unstable equilibrium. Lastly, if we start over here at 10, well, if we start at 10, the y values get pushed towards 6. So the limit as t goes to infinity of y of t, since we're starting at 10, the limit has to be 6. If we were starting at, say, I don't know, 3, the limit would be 1, because if we start at 3, we get pushed towards 1 there. So that's kind of the idea.